We're going to begin looking at the periodic table for these last two videos that we're going to have here before our test. And the periodic table is something that we've used several times already, but this shows us our elements, and we have them arranged into certain groups. We've already looked at how the periodic table is arranged into the s orbital group and the p orbital and the d orbital and so on. But those groups also have some repeating properties. We also hopefully have noticed that our periodic table is arranged by atomic number. Most of the time the masses go in increasing mass number, but not always. There are a few exceptions to that, but no exceptions on atomic number. They go in order from smallest to largest. There are a total of 7 rows, and those also are called periods. So the scientific name for our rows going across our periods, and we've already looked at those. They represent the different energy levels 1 through 7. And then we have the 18 columns. If you count the columns going across, you would have 18 total, and there are 2 different names that we use for those. Those are either called families or groups. So if you ever hear the term family or group, we're referring to the columns going up and down. Now those columns, they're called families because that's where our properties are going to kind of reoccur. So for instance, hydrogen and underneath it lithium and sodium and potassium, those kind of have the same properties. They recur over and over again. So we call those, it's kind of this part of this modern periodic law idea that we'll talk about in another slide or so. And the reoccurring sets are due to the electron configurations that are shared by those family members. So for instance, hydrogen we know ends with 1s1, lithium ends with 2s1, sodium 3s1, 4s1, 5s1, 6s1, 7s1. They have the same electron configuration, and that's what gives them the same type of property. We're also going to be looking at, in this video, about metals and nonmetals and metalloids. So we'll come back to this periodic table at the end of the video so that we can kind of mark up where those different things are at on the periodic table. I want to take a look now at the periodic law that I just mentioned. Elements within the same group. Okay, so we're looking at the columns going up and down. Those are groups or families. We just said that they have similar properties, and that the property within families though is different. So if you are looking in the period going right to left, the rows, the property that this column has going this way is the same, but going across, the property is going to change. So that's why it's called the periodic law, because as you go down to the next period, this property reoccurs in this family. So these families are going to be the same, but within the period going left to right, the property changes. So the property repeats when you move down, or when you move down to the next period, the property is going to repeat because you're now hitting you know, something from the same family. When elements are arranged in order of the atomic number, the way they are on our current periodic table, we see this repetition of properties, and that's physical properties as far as physical attributes, color, texture, you know, the type of crystals they form, whatever. Chemical properties, we've looked at those. You know, is it flammable? Will it react with water? Those types of things are going to be similar if they're within the same family. Now there are 3 classes of elements, 3 main groups that we put them in, and if we look at a period, the properties are going to start off being very metallic in nature. So metals are kind of on the left-hand side of your periodic table, and as you go to the right, you're going to be getting less metallic and eventually into the non-metals. So let's look at metals. They make up the majority of our periodic table, about 80%. Some properties or some characteristics: they are very good conductors of heat and electricity. We use metal spoons. We use metal in our wiring in our houses for electricity. They have a high sheen or luster, meaning that they, especially if we clean them up a little bit, they can be very shiny. They are all solids except for one. There is one metal, mercury, that is a liquid. Everything else at room temperature would be a solid. Another property, they are ductile. Ductile just means that you can draw them into wiring. So for instance, copper, you can obviously have that in a flat sheet, but you can also draw it into wiring, very, very thin, where we can't do that with nonmetals. And the last property that we're going to mention is malleable. When we say something's malleable, it means that you can hammer it without it being broken. So if you take a metal, maybe a machine shop, you can bend it. People use metal a lot, even in art, to make different art forms. You can bend it, twist it, make things out of it. If you try that with nonmetals, it isn't going to work. It's more brittle, so if you try to bend it, you're just going to break it. So looking at nonmetals, these have some greater variety. We can't necessarily group them all into main characteristics like we did there for our metals. Mainly they're gases. We have two exceptions, and that's sulfur and phosphorus. They're solids, and then we have one exception that's a liquid, and that's bromine. So three that are not gases. Most everything is gas at room temperature, and they're really the opposite of metals as far as our properties. So where metals are good conductors, our nonmetals are poor conductors. You don't want to use those for heat or electricity, and they're very brittle, so opposite of malleable. They, instead of bendable, would shatter very easily. We also have metalloids. That's our third class, and metalloids are kind of a mixture of our metals and our nonmetals. They kind of border the two groups, and so depending on the certain condition that you have, the temperature, the pressure, those types of conditions, that element may act more like a metal or more like a nonmetal. So those are really hard to decide the behavior on because it really is controlled by the conditions they're in. I wanted you to take a look at your periodic table, and this is probably something that you should mark on your periodic table. You're going to notice a dark black line that kind of starts here at boron. Oops, sorry, let me back up here. Get to the right setting. Starting here at boron, you have a black line, and it goes zigzags between your elements all the way to polonium there. So these are your metalloids. Anything that touches the stair step here are considered your metalloids. They are your breaking point between metals and nonmetals, and that means all of this side, these are your metals. Notice we said 80% of the periodic table, so a huge portion. Anything to the left of the metalloids are metals, and that means that all of these, from carbon around here, these are our non-metals. So definitely a lot less of the non-metals, but metals, we have definitely the more of those than anything else.